Data collected by a biologist showing the growth of a colony of bacteria at the end of each hour are displayed in the table below. Write an exponential regression equation to model these data. Round all values to the nearest thousandth. Assuming this trend continues, use the equation to estimate to the nearest 10 the number of bacteria in the colony at the end of 7 hours. So we're going to use our graphing calculator to get this exponential regression equation. So let me just start by resetting my calculator so I can just show you everything step by step. Okay, you're going to go to Stat, Edit to enter the data. So L1 for me is going to hold the X values and L2 is going to hold the Y values. So 0, 1, 2, 3, 4, 5. Those are my Y values. My X values are 250, 330, 580, 800, 1,650, and 3,000. If you want to see what the graph of this looks like, you have to turn on the plot for L1 and L2 by pressing second and then Y equals, and then you press enter and you turn on the plot. And you have to play with the window a little bit. So since our smallest x is 0, I'm going to make x min 0. Since our largest x value is 5, I could make it 5, but I want to give it some room in the graph so it looks nice and neat. So I'm just going to make it 7. Y min, I'll make 200, and Y max, I'll make 3,500. Just give it some wiggle room so everything's not bunched up. Okay, there it is. Looks like an exponential function, so all systems go. Now, to get the regression equation, you're going to press Stat, then you're going to go to Calc, then you're going to go down to Exponential Regression, or just press 0, then you press Enter. And it's given in the form of y equals a times b to the x. So y equals a times b to the x. So you got to substitute for a and for b, and we have to round everything to the nearest thousandth. So we get 215.983 times 1.652 to the x. This is our exponential regression equation. That's the first part of the problem. The second part is to use this regression equation we got here to predict or to estimate what the number of bacteria would be at the end of 7 hours. In other words, when x equals 7, what does y equal? So you can just substitute for x 215.983 times 1.652 to the 7 and see what you get there. The other thing you could do is you could just enter the regression equation in the y equals, and you could also get the estimate that way. And I'm just going to go ahead and show you. Whoops, I forgot a decimal point here. It should be 1.652 raised to the x. And once you enter that in the y equals, you can press second graph to see the table. So now you could predict what it'll be when x is 7, y is 7,252.5, and then you can just predict for any x value here. That's the advantage of this, that it's not, it just doesn't give you the y values for x equals 7, it gives you all the y values. But anyways, I digress. For this particular problem, we're only interested for the y value when x equals 7, but I wanted to show you this anyways so that you could know it. So we get y equals 7,252.5, 7,252.5, which is what you would have gotten anyways if you had just substituted there. When x equals 7, this is what y equals. Okay, now we have to round it to the nearest 10. So that's going to give us roughly 7,250 for the population at the end of 7 hours. Okay, thanks for watching. I hope that helps. Take care.